Hello, good morning to everyone. I'm Zahir. Last time we discussed about the aggregate testing. So in today's lecture, we'll discuss about the concrete testing. So basically, as you know, there are two types of concrete. One is in the fresh state and one in the hardened state. So in today's lecture, first we'll discuss about the test on the fresh concrete, and then we'll discuss about the test on the hardened concrete. So in fresh concrete, these tests in most application, it is important that the fresh concrete is fluid enough to flow into the molds without too much difficulty. Otherwise, voids may occur. What is the meaning of this? Suppose that if the concrete is not fluid enough, so when you put that concrete into the molds, so that will creates voids in the concrete that is harmful to the concrete and lowers its strength. So this means that what is the meaning of workability here? Workability is the ability of fresh concrete to flow into the molds and be compacted easily. So basically this workability is comprised of two parts. One is the ability of the concrete to flow into the molds and it is easily compacted. Now basically there are the tests which we are available for fresh concrete is slump test, that is most popular. And we have also the compaction factor test. And the third test is GB test. The first two tests you have already performed in your secondary classes, that is the slump test and the compaction factor test. So we'll discuss briefly about these tests here also. And the last is your flow table test. For high workability mixture, we are adopting the test which is known as flow table test. And we have also one more test, that is the initial and final settling time of concrete by penetrometer test. So as you see in this slide here, the slump test, as you all know, it's a very simple test which we have already performed in the laboratory. This test is performed in a conical hooper. The dimensions of the hooper are given as 100 millimeter at the top and 200 millimeter at the bottom, and the height is 300 millimeter. So this is your inverted cone here. Okay, you can fill this cone in 3 layers of equal value. So you have to divide this cone into 3 equal parts and then fill this cone in 3 equal layers. And this is your tamping rod. So you have to compact the concrete in each layer by 25 times. And when this mold is completely filled up, you have to scrape off the excess concrete, okay, and then lift the mold by using these handles and see the settlement in the concrete. So in this way, you have to perform this test. So what is the object of this test? It is performed to measure the consistency or workability of fresh concrete. Okay, and this is your reference standard. It is measured by IS 1199 1959. So determines the workability of concrete, how easily it is handled, compact, and curing. So basically, it is a combination of 3 things. One is how easily it is handled, how easily it is compact, and how to cure the concrete. Okay. Now, by adjusting that cement water ratio by adding the plasticizer to increase the slump of the concrete will give a desired mix. So if you see that the concrete workability is not obtained, okay, then in that case, you should opt for certain plasticizer to modify the properties of the concrete. So again, this is a diagram. In this way, you will see that here, this is your rod, this is your concrete here. In the first layer, you have to temp this concrete with the help of 25 times using this rod. And this is your second layer of concrete, then finally the third layer of concrete. Okay. When you remove this hopper, okay, the concrete will settle under its own weight. Okay. You have to place a ruler here, and then this vertical settlement, you have to measure it with the help of a scale. So that vertical settlement is nothing but your slump. These are some of the standard results. If suppose that the concrete is stiff, So we have the slump from 0 to 5 centimeter, and it is used for massive sections or little reinforcement. But the condition is that in case of a stiff type of concrete, you have to use vibration. Second is your medium slump concrete. The range of slump is 5 to 12 centimeter. It is used generally in the columns, the beams, the retaining walls, means in normal concrete constructions. Then we have the fluid type of concrete. Here the slump is still higher, 12 to 18 centimeter. And where it is used? It is used for heavily reinforced section and floatable concrete. Now the second test is your compaction factor test. It is again done with the help of this code, IS 1199-1959. You have already performed this test in your class at your second year level. So I will just discuss it again here. The sample of concrete is placed in the upper hooper. So first you place your concrete in this hooper, okay? Then opening the lid of this hooper so that the concrete fall into the second hooper, okay? Then when you remove the lid of this hooper, then concrete will finally fall in the cylindrical hooper. Okay, when it is filled into the cylinder, what you will do, the excess concrete remaining of the top of the cylinder is then cut off with the help of planing blades. Then the concrete in the cylinder is weighted. You have to weight this concrete inside this cylinder. So this is known as partially compacted concrete. Why it is partially? Because it is compacted under its own weight here. You did not apply any compaction, any extra effort from the outside. So the weight of this concrete in the cylinder is known as weight of partially compacted concrete. Then the cylinder is filled with a fresh sample of concrete and vibrated to obtain full compaction. Then the second time what you will do, you have to fill this cylinder with the help of concrete and with the help of vibration or some compaction mechanism. You have to fill this cylinder and again take the weight. So this weight is known as the weight of the fully compacted. Then what is the compacting factor here? Weight of partially compacted concrete divided by weight of fully compacted concrete. So this ratio is nothing but your compacting factor. So there is a standard, some results are there for different types of concrete based on the slump value as well as the compaction factor. So suppose that if the workability is very stiff, so compaction factor is around 0.70. If it is stiff, 0.75, stiff plastic, it is 0.85, it is plastic, 0.9, and the flowing is 0.95. So we'll see that in this table, if the concrete workability is changing from a very stiff to a flowing type, the compaction factor is increasing slowly. So here it is 0.7 for very stiff concrete, and for very flowing concrete, it is 0.95. The third test is your VB consistometer test. So again, in this test, gives an indication of the mobility and to some extent the compatibility of freshly mixed concrete. The test measures the relative effort required to change a mass of concrete from one definite shape to another. Now here, in this case, you have to measure the effort required to change a mass of concrete from one definite shape. For example, your initial shape is conical. So if you convert this shape to cylindrical, okay, so that relative effort which is required to change the shape of mass, that is known as your VB consistency. The amount of effort that is called your remolding effort is taken as a time in seconds. So the process which is required to convert the shape from, suppose at conical to cylindrical, in how much time it is converted, that time is called your VB time. So the time required for complete remolding in seconds is considered as measure of workability and is expressed as the number of VB seconds. So it is nothing but the measure of workability and is expressed as the number of VB seconds. This method is suitable for dry concrete. Mind you, this is very important. It is only suitable for dry concrete. For concrete of slump in excess of 50 mm, The remolding is so quick that time cannot be measured. So for example, if the concrete is very fluid in nature, so it can change the shape from conical to cylindrical in a very quick time. We cannot measure the time. So that's why this type of test is suitable only for the dry concrete, where you can measure the time easily if you are changing the shape of the mold from one to another. Then third one is your flow table test. This test is used to measure the flow value of concrete. How much is the flow value of concrete? So the equipment which is required here, flow table. This is your flow table, this one. Okay. Then we have the slump cone. This is your slump cone shaped mold, wooden tamping bar. Okay. What you will do, what is the procedure? You have to place the flow table on a leveled surface, clean the top of the table, okay, on the top surface of the mold using a damp cloth. Place the slump cone. After cleaning this table, you have to place this slump cone on the table, fill it with concrete in one or two layers and tamp each layer 10 times with the help of wooden tamping bar. So you have to fill the mold with the concrete by filling this mold in two equal layers, tamping each layers by 10 times. Then after that, then raise the table by handle. Then after that, using this handle, you have to raise the table. You have to revolve this wheel, okay, by 15 times in 15 seconds. Okay, so what will happen? This tabletop is vibrating up and down like this. The concrete is spread itself out. So what will happen? In that case, the concrete spreads out. You will see in this shape here, the concrete is spreads out because of this vibration of this wheel here. So measure the diameter of the spread concrete. You have to measure the diameter from here to here in two perpendicular directions. And then take the mean of the two diameters, okay, that shall be measured flow in millimeter. So what will be the arithmetic mean of the two diameters? Okay, that is called your flow table in millimeters. Now come to the hardened concrete. What are the tests which are performed in the hardened concrete? So what is the properties of hardened concrete? Properties include high compressive strength, that is 15 to 55 MPa. Then we have low tensile strength, which is roughly 10% of the compressive strength. So here it is 1.5 to 5.5 MPa. As you know that tensile strength of concrete is very less, it is around 10%. Fair to assume that the concrete sample tensile strength about 10 to 15% of its compressive strength. You can assume any value between 10 to 25% of the compressive strength of concrete as the tensile strength. So what you will do for measuring this property, that is a compressive strength of concrete, either you are using 150 mm cubes, which are generally used in India and UK, and you are also using 30 centimeter diameter, 300 millimeter diameter cylinder. The diameter is 300 and height is 300 millimeter. No, it is, I think it is wrong. This is 150 millimeter in diameter and 300 millimeter in height. Okay, so please make a correction here. This is 150 by 300 mm. It is used in USA, Canada, and Australia. So for that, you have to require minimum 3 specimens for testing the strength of concrete. Now suppose that if the individual strength varies plus minus 15% of the average strength. So you, after testing these 3 specimens, you have to take the average strength. If the average value, if the individual strength varies plus minus 15% of the average, then reject such sample result. Okay, you have to reject such sample if the strength varies by more than 15%. Now what is the acceptance criteria for concrete? Suppose that for M20 concrete and above, these are the 3 criteria which are given in the IS code, IS code 56. Now suppose that this FM1 is greater or equal to FCK plus 0.825 times S. S is your standard deviation. For M20 concrete, S is equal to 4. So what is this Fi here? Fi is the strength of any individual sample, and FM1 is the mean strength of the sample. So the first criteria of acceptance is that the mean strength is greater or equal to FCK plus 0.825 times the standard deviation, which is 4. You see, this is first criteria. Second criteria is FCK plus 4 MPa. So the mean strength should always be greater or equal to FCK plus 4. Suppose that your FCK is 20. So 20 plus 4. So every individual test results, okay, of the cubes or the cylinder should be more than 24 MPa. 20 plus 4, that is your 24 MPa. And any individual test result Fi should be greater or equal to FCK minus 4 MPa. Suppose that your FCK is 20. So 20 minus 4 is 16. So any individual test result should be greater or equal to 16 MPa. So these are the criteria for measuring the strength of concrete. Now, what is split tensile strength? Ft is equal to 0.7 times under root of FCK. Very simple. Flexural strength, it is carried out in two types of tests. One is your central point loading method, that you have to apply a central point load on the beam to calculate the flexural strength test. And second is again a second test, that is called your third point loading method. You have to apply 2-point loads at equal distances from the support. Okay, that is called your third point loading method. Now, what are the ASTM tests for cylinders? In India, we are calculating the strength of concrete by using the cubes, and for American standard, we are using the cylinders, these types of cylinders. Now, the strength is affected by L by D ratio. So naturally, the L by D ratio is 2. So what will happen? Because the height is more, so the strength comes out in the cylinder will be less as compared to the cubes. So I will discuss what is the factor, why the strength comes out to be less in case of cubes after a few minutes. So the loading rate which is used is 140 to 350 kPa per second. Calculate compressive strength of the specimen as follows. So this is compressive strength. Fc is equal to P divided by pi by 4 d square. Okay. Which one is more reliable? Now the question is that whether the cube strength is more reliable or the cylinder strength is more reliable. Now the answer is that in cubes the specimens are placed on the smoother side during testing. So you have to place in that, when you put this cylinders in the testing machine, you have to put it in this fashion, the vertical position. You have to apply the load from the top, okay, and there is a steel plate here. On the smoother side during testing, other than the casted position. Now what will happen? The cylinders are casted in this fashion, means vertically they are casted. Okay, this is a mold, vertical mold is there. You have to fill the concrete and then casting in the vertical direction. And then testing is also done in the same direction. So this is more scientific or more logical. Okay, but in case of cubes, what will happen? Yeah, because cubes heads, every 3 sides are equal. So you are filling the concrete cube in one direction and then testing the concrete is not in the same direction. Maybe either it is in the same direction or it may be not, but the chances are that it may be not, because you have to test your cube specimen on the smoother side during testing. So smoother side, naturally the vertical sides of the cube, not the top and bottom sides. So that's why due to this reason, the strength of cylinders are more reliable than that of cubes. So got the point? Now here the cylinder strength is around 0.8 times the cube strength. So it is cylinder strength is only 80% of the cube strength. Now if you test the cylinder, so what are the different types of cracks which you obtained? So you see that if you are getting the vertical cracks like this, so that is called your splitting. If in the bottom, in the central portion, we have this vertical shape here, and here it is conical from the top and bottom, then it is called your shear failure. That is called your shear or cone failure. And third one is your splitting and shear. So here in that case, you will see that the vertical cracks also here and cone is also there. So this is your combined type of failure. So basically three types. Splitting means only vertical cracks. Shear means we have some conical shape at the top and bottom, and splitting shear means the combined form. Now these are the different, you can say that the shapes of the during the compression testing of the cracks. Vertical cracks are there. We have some bulging here. We have this type of cracks. Okay, here we have vertical cracks here. Now suppose that if you test your cubes here, so basically these are the failure in the cubes. So the A part, this one is this is your non-explosive here. So when you apply the load, the vertical cracks are appearing here, okay, and we have this the concrete is spells off in this region. So that is called your non-explosive type. And we have, suppose that if complete cone is formed here and the concrete is removed by force from this side, that is called your explosive failure. So what is the ideal failure here? Vertical cracks are there, which is rarely achieved due to the rough contact surface between the cube and the plates. We have the plates here and we have the cube surface. There is a rough surface between top and bottom. So due to this reference, the vertical cracks are rarely achieved. Okay, so most of the time when you apply the load from the top, okay, in this direction, so it is failed by Poisson's effect. That is, laterally the strains are increasing. That is, it fails by Poisson effect. And you know the value of Poisson's ratio is 0.3 for steel and 0.2 for concrete. And we have explosive failure, that is two truncated pyramids formed, which is generally it is happen in high strength concrete. So this type of failure happens in the high strength concrete, that is HSC. Now what is tensile strength? Now this strength is required for design of elements subjected to shear, torsion, shrinkage and temperature effects. So you know that if you are calculating any shear resistance of concrete, so that case require the shear tensile strength. If you are measuring the torsion, if there is shrinkage or temperature effects, okay, then in that case you require the tensile strength of concrete. Or if you design a pre-stressed concrete structure, then in that case you require the tensile strength. In liquid written structures which are always in tension, which is again tensile strength of concrete is required. In runways also. So it can be measured by the following test. One is direct tension test. Second one is a splitting tensile test, that is more reliable. And third one is the fractal test. So I will discuss these two tests here. The code discard this type of test which we have performed in the olden time on the cement briquettes, that is called direct tension test. So we are more concerned now with the splitting tensile test and the flexural test. Normally tensile strength is assessed using flexural or split cylinder test. So what is split cylinder test? Here the cylinder is placed in the compression testing machine in this fashion, along with the height in as in the laid position. Okay, and then this is your laid position of the cylinder. Okay, we have that laid from the top and the bottom, and then apply the compression from here. So this is your second test, that is the flexural strength center point loading. So we have casted a beam specimen here of length L. This is your depth of the specimen, rectangular specimen, and we have to apply a load P here. Okay, that is called your central point loading. So because here in that case, if you draw the bending moment diagram, so bending moment is maximum at the center and 0 at the supports. So we have this, and we have the shear also. Okay, so this is nothing but your combined flexure and shear. So we see that here in this case, you'll see that in this diagram, this is your long beam here. It is tested using the central point load here. Okay, and this is your failure of the beam here. Now come to the third point loading. Again, the flexural strength, third point loading, that is called your pure bending. Now pure bending, when you apply a point load here and here, and these two are the supports here. Okay, so these point loads are placed at equidistance from the support here. So this is here, D here, D here, and D here. So you have to divide the specimen into three parts. That is the specimen from center of one support to the center of other support. D, D, D. So this is called your third point load. Now, if you draw the bending moment diagram, so between this load and this load, the bending moment remains the same. It is a horizontal line here, and here it is inclined. So this region, that is your central region, is under pure bending. That's why this test is called your pure bending test. Okay, this is your the uh, other diagram of this here. This is your this is our supports here. This is your specimen which we have tested. This is one point load. This is another point load, and this is your load which is coming from the testing machine. Now we have also performed a test on the concrete that is called your core testing. Okay, sometimes when we require this core testing, sometimes the structure after its construction did not perform properly. So what do we do? We have to test the concrete, whether the grade of concrete which is used in the structure is okay or not. So what we will do? We have to take some samples from the concrete or the constructed structure, okay, and then test those cylinders, okay, in the test in the laboratory, and finally we get the report that whether the concrete which is used in the structure is okay or not. So that is called your core testing. We are required by the architect or engineer obtain codes in accordance with ASTM C42M. This is the code by which you have to take the course. The codes for load bearing elements minimum 100 millimeter diameter. So this is a one such type of core. This is your core cutter machine. So when you place this core cutter machine over any concrete surface and then start it, what will happen? It will cut the concrete. You will take out this cylinder. Okay, the diameter of this cylinder is minimum 100 millimeter, which is required as per the ASTM code. So the number of test codes will not be less than 3. Again, 3 minimum codes are required. That should represent the whole of the doubtful concrete. So where you have a doubt in the concrete, you have to take out the cores at least at 3 locations. The core strength should be converted to equivalent cube strength. How it is converted? The cube strength is about, the cylinder strength is only 80% of the cube strength. So using that relation, you have to calculate the cube strength. Now, if the average equivalent cube strength of cores, if the average equivalent cube strength of cores is more than or equal to 85% of the cube strength of the grade of concrete, and no individual core has a strength less than 75%, the strength of the concrete can be considered adequate. So which concrete we call it as strength concrete, the good quality concrete? Number one is that the average equivalent cube strength should be greater or equal to 85% of the cube strength. So you have to convert the cylinder strength to the cube strength, and if this is more than 85% of the cube strength, then it is okay. And second criteria is no individual core has a strength less than 75%. So in another case, individual core should not have a strength less than 75%. So this is all about this lecture, that is strength of concrete. So in this lecture, we'll discuss two things. First, we'll discuss about the fresh concrete, and then we'll discuss the strength which we have to perform on the hardened concrete. So in the next lecture, we will discuss about the non-destructive testing of concrete. Thank you very much. Thank you.